percentage of anhydrous salt A is 37.05. Percentage of anhydrous salt B is 85.48. Percentage water of A is 62.494. Percentage water of B is 14.52. Show that this number illustrates chemical law. Solution. Anhydrous mass of anhydrous is equals to 37.06 divided by 62.95. For that of B is 85.48 divided by 14.52, which we have 0.59 over 1 and 55.88 over 1. The mass of anhydrous salt, which combined with fixed mass 1 gram of water, are obtained in the ratio of 0.59 is to 5.88. That is 1 is to 10, which is simple ratio. Therefore, the number illustrates the law of multiple proportion. For example, 10. Assuming we have elements in a CHO in a compound, then the relative mass of C is 2 gram. The relative mass of H is 0.34 gram, and the relative mass of oxygen is 2.67 gram. Then the molar mass of carbon, we know it as 12 gram per mole. That of hydrogen, we know it as 1 gram per mole, and that of oxygen, you know it as 16 gram per mole. To find the molar ratio, you say that the relative mass over molar mass, which is now going to give us, for carbon we have 2 divided by 12. For hydrogen we have 0.34 divided by 1. For oxygen we have 2.64. T7 divided by 16. Therefore, the molar ratio is 0.17 is to 0.4 for carbon, and 0.34 for hydrogen, and 0.17 for oxygen. Therefore, the molar ratio divided by simple less mole will give us the empirical formula. Therefore, we have 0.17 divided by 0.17, which will give us 1. 0.34 divided by 0.17, which will give us 2, and 0.17 divided by 0.1 will give us 1. Molar ratio is equal to 1 is to 2 is to 1. Empirical formula is CH2O. Relative molar formula equal to empirical formula, where N is equal to multiple factor. Relative molar formula is equal to CH2ON, which is equal to 60. Then N is equal to relative molecular formula over element mass, which is equal to 60 over 12 plus 2 times 1 times 16. The molar formula of compound is C2H4O2. Chapter 5. Calculation of masses from chemical equations. Calculation of masses from chemical equation. For calculation of masses from chemical equations, it is very important that the formula for the compound are correctly written, and that any equation of the reaction is correctly balanced. Example 1. A. Give the equation for the reaction between calcium trioxocarbonate 4 and the triosonitrate 5 acid. B. What mass of calcium trioxocarbonate 4 is needed to give 0.25 mole of calcium triosonitrate 5? Solution. For the question A, we are asked to balance the chemical equation of calcium trioxocarbonate 4 with reacting with triosonitrate 5. which will give us calcium triosonitrate and water with carbon 4 oxide. To balance the equation, since we have we have two nitrogen, we have two hydrogen in the oxygen, but we don't have two hydrogen in the oxygen. We add two, but since the two hydrogen in the triosonitrate acid has changed the number of nitrogen to 2, we now, inside the calcium triosocarbonate, we now add 2. Then if you check, your oxygen is balanced because you have 6 on the reactant, and there are 6 oxygen in the product. We have 1 calcium at the reactant and 1 calcium at the product. We have 2 hydrogen atoms at the reactant, 2 hydrogen atoms on the product, and the 3 hydrogen oxygen atom at the reactant, 3 hydrogen oxygen at the product. So based on the equation above, 1 mole of calcium tetraoxonitrate 4 is produced by 1 mole of calcium carbonate, that is 0.25 mole of calcium triosocarbonate 4 is produced by 1 mole of calcium triosocarbonate. But molar mass of calcium triosocarbonate is equals to 40 plus 12 plus 2, 3 times 16, which we have 40 plus 12 plus 48, which will now give us 100 gram. The mass of 0.25 mole of calcium carbonate will now give us 100 times 0.25, which will now have 225 grams. Example 2. What mass of sodium oxide Na2O could be obtained by burning 11.5 grams of sodium in the air? Solution. Equation of reaction. 4 atoms of sodium react with 1 atom of oxygen to give 2 atoms of sodium oxide. Thus, 4 moles of sodium bonds to produce 2 moles of sodium oxide, but mass of 4 moles of sodium is equals to 4 times 23, which will give us 92 grams. Mass of 2 atoms of sodium oxide will give us 2 times 23 times 2 plus 16, which will give us 2 times in bracket 46 plus 16 grams, which will give us 124 grams. Yes, these units are important. Gram, that is 92 of sodium bonds to produce 124 grams of sodium oxide. 11 grams of sodium bonds to produce 124 divided by 92 times 100, 1 times 11.5 gram of sodium oxide, which will give us 15.5 grams of sodium oxide. Example 3. What mass of carbon 4 oxide is produced by heating strongly 8.4 gram of sodium hydrogen tricarbonate 4? What mass of carbon 4 oxide is produced when excess dilute hydrochloric is added to the residue? Solution. Sodium hydrogen triosocarbonate 4 decompose on heating as follows. 2 atoms of sodium hydrogen triosocarbonate will decompose to sodium triosocarbonate and the carbon 4 oxide plus water. From the equation, 2 moles of sodium hydrogen triosocarbonate when heated produce 1 mole of carbon 4 oxide and 1 mole of sodium triosocarbonate.